Hi everyone, thank you for coming to support all of us mentees. This has been a really awesome experience for me. For my mentorship program, I built a Flask App for a community science project, and my name is Victoria Reese. I'm going to talk more about what I did. Has anyone in the room seen one of these before? Like few people. So this is the tree of life. It's super cool. This basically outlines all of the species that we know exist on the planet now. We've named it, we've located it in the tree of life. But it turns out that about 86% of species on the planet are not classified at this point in time. And that's an issue. We need to know how, what biodiversity exists on the planet. So I work at the Field Museum. At the Field Museum alone, we have 40 million specimens. Many of these also have not been classified yet. And for my Flask app, for my mentorship program project, I teamed up with a Field Museum researcher who studies bryophytes. In the Field Museum collection, we have 250,000 bryophyte specimens, but only about 45,000 of those are classified. So I was interested in helping with this problem. If researchers alone tried to classify all of the specimens we have in the Field Museum without any help from the outside world, it could take decades for us to finish that up. So, there are some options of how we can deal with this problem. And one of those options is using community science. Community science is basically outsourcing the problem of research to normal people. There's a popular platform that exists online. It's called Zooniverse. Has anyone heard of Zooniverse before? There's some cool space research projects on Zooniverse that are pretty popular. But the Field Museum researchers have basically taken a bunch of photos of all of the specimen in the bryophyte collection, loaded them up onto a Zooniverse project called Microplans, and made it available to the public. So a volunteer who's interested in helping out with classification can log on to the Microplans project and help by measuring a little structure on the bryophyte called a lobule. And these lobules are super cool. The width and height measurements are taxonomically or phylogenetically informative. So they give us a hint as to what species it might belong to. And so we can use this information to see if maybe there's even species that are yet undiscovered in the Field Museum collections. So far, this project has discovered 4 new species of bryophyte, and we're only hoping to do more. So what did I do, and how does it relate to code? So Zooniverse has a great data dump function. You're able to go onto the website and access all the classifications that volunteers have created since the beginning of the project. But when you download it, it's kind of messy. You've got a lot of null values, you've got a lot of JSON, nested JSON data. When I first started the project, I had no idea what JSON was. So I was like, what? We need to pull out values from here. So I had to figure out, basically working with this researcher and my mentor, how do we pull out these values and how do we make this data useful to the research team? So I wrote a Flask app. It's very, very simple. It looks like this, and you just take your CSV that you downloaded from the Zooniverse website. It runs it through a series of cleaning and calculation scripts that I wrote using pandas and a little bit of machine learning, but actually that's the next thing. And then it produces a clean data sheet that looks like this. So you've got the intersection point between the axes that volunteers have created. You've got the axes length, and then you can go on to do a bunch of interesting data visualizations and analyses with this data. So I just was kind of testing out what can we do with this data, and I implemented a density-based spatial clustering algorithm. So these dots all represent different intersection points of lines that volunteers drew. And this actually, each cluster corresponds to a lobule. So we can use this machine learning algorithm to weed out the bad points, because since we're working with volunteers, we can't really depend on all of the data being perfect. So we have to find ways of basically cleaning the data to be even better and going from there. And areas for the future. I would love to do some in-app data visualization. I would love to be able to support more than just the microplants project. I'd like to get this up and running on the Field Museum server, still working on that, and then to make it prettier. So, yeah. Thank you. Oh, thank you. Thank you. Oh, those are the tools I used. And thank you so much to the organizers. You guys are the best. Also, thank you to my mentor, Will.
Questions?
So what do you mean by classification? Like at a species level? Or
Yeah. Basically, can we separate, can we parse out the different species of the specimens that we have in our collection?
if you discover a new species, you get to name it?
I think that usually, yeah, I guess you could. I didn't, but maybe I'll ask. I would love to have a species named after me. That'd be cool. Yeah. Way in the back.
So how'd you end up meeting this researcher and finding out about this issue that they were having all this trouble classifying this particular family of organisms?
Yeah. So the question was, how did I meet the researcher? How did I find out about this problem? So I work in the education department at the Field Museum, and I'm really interested in how we can get normal people involved in science. And I basically Googled, like, Field Museum citizen science. It's now called community science because that's more politically correct, by the way, so sorry. So yeah, I just found out that a researcher, his name's Matt von Conrad, is working on citizen science, and I approached him, and he's very nice. So I decided, we could work together.
Cool. One more round of applause. Sorry, we
Okay.